So this pre-assessment was around the fair price. So most of you, in fact, I think all of you were able to get number 1 correct. So I'm not even going to talk about that very much because it's straightforward in this case. Jasmina, so we're talking about relating the price of an object to how much bigger it is if you're scaling up, right? So here you have a large candy ring of 8-inch diameter, right? So that's 8 inches. And a small candy ring of 4 inches diameter. So you've doubled the diameter, right? And Jasmina says, I get the same amount of candy from 2 small rings. So if she made 2 small rings, as she gets from 1 large ring. Because we're talking about circumference here. So notice that we're comparing length to a length. A circumference is all about a length, right? So is Jasmina correct? Yes, because this is a double length. And when you double one length in a piece, you're gonna, the circumference is dependent as a length on this length, so it'll cause a double of the circumference, right? So you write y, but like I said, most of you got this correct. So if you've already done this, you don't need to correct it. And then here, if the price of a small candy ring is 40 cents, what's a fair price for a large one? I think every student got 80 cents. And again, you need to explain your answer for why that's true. But again, it just has to do with the circumference really is double. But the next problem is the one that a lot of students ended up having struggles with. Here we've got a pizza, right? So a large pizza has a diameter of 12 inches here. The small pizza has a diameter of 6 inches. So again, we're doubling the diameter, right? But does that mean that we're doubling the area? So she says, I get the same amount of pizza from 3 small pizzas as 1 large pizza. So she thinks that 3 of these is going to be this. And most of you said no, but most of you said no because you thought it was only double. And that's the problem here, is that you're thinking, oh, I doubled the radius, so I must have doubled the area. But there you're comparing a length to an area, and that's not directly proportional. When it scales differently. So it's really best, if it's not clear to you, to just go ahead and figure out what the areas are. You have the formula right here for area of a circle, right, is pi r squared. So use that. You know that the area of the pizza is 3 squared, pi times 3 squared. So this is the small. And the area of the large pizza is pi times 6 squared. So this is 9 pi, and this is 36 pi. And again, I'm leaving the pi in there because that's not going to help me see how many times bigger. I get to deal with whole numbers now. And if you notice, the large pizza is actually 4 times bigger. So do you get the same amount of pizza from 3 small? No, not correct, right? So the answer is no. And then you need to explain why. And the reason here is that it's actually 1 large pizza is the same as 4 small pizzas. Okay, if you double the diameter of a pizza, you actually quadruple the area of the pizza. So then if the price for a small pizza is $3, a fair price for a large one actually would be $12. And you need to, again, explain your answer, but it has to, it's quadruple. The area is quadruple. So now we get down to the cone. So we're talking about filling a cone of popcorn, and that means we're talking volume now. So we've got a radius of 2 inches for the small one and a height of 6, right? 6 inches. And here we've got a radius of 4 inches and a height of 12 inches. So again, we're dealing with doubling, right? But in this case, you're doubling the radius and you're doubling the height. And Jasmina thinks that she gets the same amount of popcorn from 2 small cones as 1 large, right? So if she just did 1 more small cone, that would be the same as the volume of this. It's just you double these lengths, and so you're doubling the volume. That's what Jasmina's thinking. But hopefully after the project that we did, you guys aren't going to fall into this trap. Again, you're doubling a length. You can't assume that that means that you're doubling the volume as well, because what happens to volume often is compounded. So again, let's test this out. So we have the formula for volume of a cone, right? It's 1/3 pi r squared times h. So let's just calculate these two areas, these two volumes. So 1/3 times pi times radius squared times 6, the height. This is for a small cone. And then for a large, it's going to be 1/3 pi times 4 squared times 12. So I want you to look at what's happening. I've doubled this length, right? But I've effectively done that twice because I'm going to be squaring it, and I've doubled this length. So even if we just ignore these two right here, because those factors are going to be the same, these numbers right here, 4 times 6, 24, and here, 16 times 12, this is 8 times bigger, right? This volume is going to be 8 times bigger. Now you could have multiplied out by pi and 1/3 and pi and 1/3, but those two aren't going to, you're just multiplying the same number. So to figure out how many times bigger, you could have multiplied it all the way out and found it, or you can just notice what actually changed. And what changed was you doubled the radius, which is squaring, so it's basically like 2 times 2 twice, and then you doubled that, so 8 times bigger. So the answer is, again, no. You need to explain why. And then if the price for a small cone of popcorn is $1.20, a fair price for the large one actually would be be 8 times more. So 8 times 120 is actually $9.60. So what happens to volume and area isn't always as obvious. You really need to stop and think what's happening to all the lengths and how that impacts the volume or the area because you're being multiplied together.